All right, everybody say hi, Abigail.
Hi.
We hope you are recovering well from your wisdom teeth. There you go, from your tooth extraction. We are on example 5 on section 10-2. This is where we're at right now. And what I want you to do, for those of you, for everybody, I guess, the law of sines. Let's write down the formula at the top of the page. It's one that you can memorize pretty easily. It is just sine A over A equals sine B over B, involving two sides, two angles, right? Capital letters are angles, lowercase letters are sides. So you literally do sine of an angle over top of its opposite side, right? Like A and A, they're opposites of each other, equals sine B over B, and you use that proportion to solve for something that you're missing, right? Okay? All right, so that's the formula that we've been using all the way through here. They want us to solve this triangle using this information. All right, so I'm going to kind of read through this real quick. We have the diagram. That's going to be what we use to help us the most. A plane, which is right here, is flying to the right, whatever direction that is, and it's flying in a straight line parallel to the ground, passes directly over point A, and point A is here. So it's directly over top of point A. And then later, it is directly over top of point B, which is just down here in the bottom. And then it continues on, and it gets to the point where it's at C up here at the top. So it's to the right of both A and B, the points below. Maybe there's people standing there, but it's flown over top of both of those people standing there, and now it's to the right side of them, okay? The angle of elevation from A to the plane is 43 degrees. So they have that mapped out right here. And the angle of elevation from B to the plane is 67 degrees. That's important. They want to know how high the plane is at that moment, okay? So they don't even tell us what we're solving for in this diagram. What are we solving for?
H.
They want to know the altitude of the plane, which is from the plane all the way down to the ground, but at a 90-degree angle. So we're solving for H, okay? And there's a reason why they give us a bunch of pieces of information, because H has to be solved like very last. We need to solve for a couple other things. By the way, there's 3 miles in between A and B, so that's important. But if you look, we have this triangle right here, this guy, right? And we need to maybe, let's start from H. Let's see what we need to be able to solve H. H is in this triangle right here, which we said was a right triangle. And since it's a right triangle, we can use SOHCAHTOA, right? Yeah. SOHCAHTOA. So in order to be able to solve for H, we can use SOHCAHTOA. And we do know the angle, which is 67 degrees. But I have to know one of the other sides, right? So do I know the bottom side? No. Do I know A? No. But they have it labeled as A, which makes me think that we're going to have to solve for him first, right? So as soon as we have A figured out, then we can use SOHCAHTOA to find what H is, right? Yeah? Okay? So let's solve for A here first. All right, let's see what we have. This triangle here is not a right triangle, so we can't use SOHCAHTOA. We have to use law of sines, right?
So
okay.
Sine of 43 over A.
So law of sines says sine of 43 over A, okay? Because those are opposites, right? 43 and A are opposite each other. But then we have 3, and we need to know what this angle is right there. We need to know his opposite, right? What's that?
180 minus 67, it's 113.
Okay, so 113 is this bottom angle right here. Do you guys see how she got that, or they got that? 67 is the one side, 113 is, so can I use that to find this angle up here and then use that in my formula? 113 plus 43, subtract that from 180, it's a really tiny angle. That's right. 24 degrees, so that's important because I can use that opposite 3, right? You see how those are opposites? So 43 and A are opposites, 24 and 3 are opposites. We don't actually need the 113, but we needed it to get to the 24.
So we don't need the law of sines.
We do need the law of sines because this is a right triangle. This is not a right triangle. So we've already set up sine 43 over A, and the other side is sine of what?
24.
24 over his opposite is 3. Okay? All right, so then if we write this out, if we cross multiply, we have 3 times sine of 43 equals A times sine of 24. And how do we get A by itself? Divide by sine 24, right? So 3 sine 43 divided by sine 24. Make sure you close off your parentheses after the 43. 5, exactly? No.
5.03.
5.03, 5.0, we'll just go 5. Sure, I like it. A is 5. Awesome. I'm going to erase some stuff. All right. A is 5.0, or just 5. Nope, we got to solve for H, right? We have to solve for H? Okay, so now, what do we do now? Do we remember?
Now we do the next one.
Now we can use SOHCAHTOA. How do we get away with using SOHCAHTOA and not the law of sines?
Because it's the right triangle.
Because it's a right triangle.
It's a right triangle. Now, let me give you this. What's angle D down here at the bottom? 90. So technically these two are opposites from each other, and these two are opposites from each other. So we could do the law of sines if you wanted to.
No.
You could totally do the law of sines if you wanted to, right? Sine of 90 over 5 equals sine of 67 over h. You could totally do that, and it would work. But we could do SOHCAHTOA instead. Do you want to do that instead?
Yes.
Yeah, since that's what you're familiar with. So we want to use 67 is the angle that we want. 67 degrees. H and A, opposite and hypotenuse.
Sine.
Okay, opposite hypotenuse. So sine of 67 equals opposite over hypotenuse. H over 5. Then we just multiply 5 to the other side. 5 times sine is 67. 4.6 is the height. Yep. That makes sense because if 5 is the hypotenuse, it's got to be smaller than 5, right? So what does that mean? 4.6 miles in the air is how high that plane is, right? Are we in miles, I would assume?
Yeah.
Unless we're in kilometers. But I think it's miles, 3 miles right here. So 4.6 miles is the units. Okay, does that make sense? You can very well, anytime you have like the SOHCAHTOA stuff, you can always use the law of sines with the 90-degree angle. But if it's a right triangle, you can use SOHCAHTOA. Okay, good? All right, now this is stuff that's not the law of sines. This is a formula for finding area of a triangle. Okay, let's do this. Look at this triangle right here. I'm gonna show you how they get this formula. Area of a triangle is 1/2 base times height. Right? Did you know that?
Yes, we just
1/2 base
learned
times
that.
height. Yeah? Why is it half?
Because it's half of a
It's half of a rectangle or half of a square, right? 1/2 base times height. Except that would be if it was a right triangle, right? Like if this is 6 and this is 8 and this is 10, you would do 1/2 times 6 times 8, right? Half of 6 is 3. 3 times 8 is 24. So the area of this thing would be 24 units squared, right? Okay, but what happens if your triangle looks like this instead, and it's not a right triangle? The height is not the length of A. This is not the height right here. The height is perpendicular to the base, right? So the height of this triangle isn't even a measurement on the triangle. It's this height over here, right? Yeah? Does that make sense? Okay, so what we need to do is we need to look at the formula 1/2 base times height. Up here, and we need to figure out how we solve for the height, right? Okay, and I'm just going to do this so that you know how this formula is set up. Okay, so just bear with me here. I'm gonna look at the 1/2 base times height, and we're gonna come up with this formula, and then you'll never have to think about it in terms of this again. But I want to show you why we get this. Okay, in this triangle, what's the name of the base? If we do 1/2 base times height, what is base? What is the base called? It's still called B, so we're going to leave it as B, but now we're trying to solve for this height, right? Okay, and we have a right triangle here, this right triangle, and we want to use SOHCAHTOA to figure out how to solve for H, right? So what's the angle that we can use? If we're looking at, you can't use 90. Angle C is this angle down below here, right? Angle C, okay? And H, and we have A right here, which is one of the sides of the triangle, right? Okay, so H is the opposite, A is the hypotenuse, okay? So in terms of C, we're using sine of what? Sine of C is equal to, the opposite is called H, the hypotenuse is called A, right? Okay? Do you see where we get that? We're just using SOHCAHTOA to find that, okay? Now, if we want to get H by itself right here, I just need to bump the A to the other side by multiplying by A. You see that?
Yes.
So the H is equal to A times sine of C. So in my 1/2 BH, or 1/2 base times height, I have 1/2 B times A sine of C. Do you see how that works?
Yeah.
Okay? Those are the things that you're going to multiply together. Do you see where they come up with that formula? 1/2 base times height. It's just that the height is not given to you. You use this other stuff in the triangle to find out what the height is. Okay? Now, let's take a look at this. For this formula, we have 3 things involved. We have B and A and angle C. This is the only angle that I have. And then B and A are 2 sides, right? These are my sides that I'm given. If I'm trying to find the area of this triangle, I have 1 angle and 2 sides that I need, okay? Now, the 2 sides are named B and A, but it doesn't really matter what the names are, okay? What do you know about B and A in comparison to angle C?
They have to be less than
No, not necessarily. Where do they live in comparison to C?
1,000.
This is angle C, right here. Where does A and B have to live then?
To the left and right.
To the left and to the right. So here's what happens when you're finding the area of a triangle. It doesn't matter what they're named. They could be angle C could be named Z or W, whatever. But whatever angle you have, the 2 sides that you need for your formula must be the 2 sides that are touching that angle, right? It can't be the one that's across from him. Does that make sense?
Yeah.
When you're finding the area of this, whatever angle that they give you, the 2 sides that you need also in your formula have to be the 2 that are touching that angle, right? Not the one across from him. That's the way that it's set up in the formula. It doesn't necessarily mean it has to be side A and side B and angle C. It just means the angle that you have, the 2 sides have to be the ones like not across from him. Does that make sense? Let's go down to this diagram right here. Here's the angle that I have. They don't even name it angle C. It has no name, right? It's 130. But the 2 sides that I have, are they the correct sides?
Yes.
They're the ones that are touching that angle, right? 8 and 13. Okay? So if I want to find the area, I do 1/2 the base times the height. But base times height is AB sine C. And it doesn't really matter what they're named. We just need to make sure that the 2 sides are the ones that are right next to the angle. And we just plop them in, right? So 1/2, what do you want A to be? 8. And B is 13. And then I want to do sine of 130, okay? I would do them in that order. It doesn't matter which one is A and B. You could flip these 2 around, but which one's easier, 1/2 of 8 or 1/2 of 13? 1/2 of 8, right? Because before you type this into your calculator, you can reduce some of this. 1/2 of 8 is 4. Now you just have to take 4 times 13, right? 4 times 13 times sine of 130, whatever that is. 62 exactly.
I don't know, I did that in my head.
Oh. That is, I think 52. 52 sine of 130. What is it?
39.8.
39.8 centimeters.
I know. So
Centimeters squared, because we're finding the area, right? Whew. Crazy. Okay, good? Do you see how they get that formula, though? 1/2 AB sine C, that stuff, okay? It's just another way of saying 1/2 base times height, but the height is calculated by B sine C, okay? Now, the last formula is another one for area, but this is called Heron's formula, and I'm not going to show you the proof of how they get this because it's really long and ugly. But this is used to solve when you have the 3 sides of a triangle. We'll call them A, B, and C. When you have the 3 sides and none of the angles, this is the formula that you use to find area. You don't have any of the angles. You just use those 3 to find the area of a triangle. Here is what it is, okay? It is the square root of S times S minus A times S minus B times S minus C. So you have basically 4 parts inside of your square root. And S is calculated as 1/2 of A plus B plus C. I'm never going to have you memorize this formula. I'll give it to you. But you have to know how to plug stuff in. So the first thing that you want to do when you have all 3 of your sides is calculate what S is, right? So my sides are 7, 9, and 12. 7, 9, 12, and I want to calculate S. S is 1/2 of 7, 9, and 12 added together. 1/2, 7 plus 9 plus 12. So take 7 plus 9 plus 12 and divide by 2. 14, perfect, okay? Then to find the area, I just take the square root of 14 times those other 3 pieces. And inside of here, it's 14 minus 7, 14 minus 9, 14 minus 12, okay? Since that comes out really nice, let's do sum in your head before you type it into the calculator. 14, what's 14 minus 7? 7. 14 minus 9? 5. 14 minus 12? 2. You can do some of that in your head, right? Maybe? Yeah? Really, I can take 5 times 2 and take it times 7 also. Okay? That's going to be the area. $31.3. And that is in,
Wait, Michelle, you don't have to do the one.
so we call it units.
All on the back side.
And it is units squared because we're still doing area. Okay? So 2 different area formulas based on what you have. If you have all 3 sides, you're going to use Huron's formula, which is the name of a dead guy who came up with this formula for area. If you have one of the angles, you're going to use the other formula.